Good afternoon. I am presenting a paper entitled The Effect of Age on Perceptual Speed. My name is Diane Damos, and I'm the president of Damos Aviation Services, and my co-author is Dr. John Trent of the U.S. Air Force Personnel Center in San Antonio, Texas. Our study was designed to answer two questions. The first is what age range produces the highest scores on perceptual speed tests? And second, when does performance begin to decline? We were predominantly interested in perceptual speed tests for pilot selection, and therefore we limited participants to an age group where people were likely to be hired by an airline or accepted into flight training by a military. So we wanted studies using people who were at least 17 years of age and less than 65 years of age. Again, because we were primarily concerned with using perceptual speed tests for pilot selection, we only looked at studies that used non-clinical populations. We examined three different sources of information. The first, of course, was refereed journal articles. The second was test manuals of cognitive test batteries that we knew had been used in pilot selection. And the third were studies conducted by myself and my co-author, Dr. John Trent. And between the two of us, we had conducted 3 studies on perceptual speed. We wanted to be able to compare all of the results from all of the studies on the same scale to make interpretation easier. For that reason, we decided to try to transform everything to t-scores. For the 3 studies conducted by Dr. Trent and myself, we calculated the t-scores over the population as a whole and then calculated them, of course, for the individuals. Some of the studies we were able to obtain presented their results as t-scores. Other studies had sufficient information to allow us to calculate the t-scores, but in a few cases, however, information was missing and we could not do the conversions. Another problem we had was small sample sizes. This was a particular problem for upper age groups. John and I arbitrarily decided that the minimum group size was 7 cases. We realized that this is small, but again, most of these studies had few applicants who were in their 40s or 50s or 60s. We wanted to be able to show as much data as possible, so we set a fairly low sample size. We conducted the literature search first by using the term perceptual speed. This is the more modern term for this ability. So we also used the term clerical speed, which is the more traditional term. This allowed us to ensure that we could find the older literature. We did find a lot of studies that had perceptual speed or clerical speed as keywords, so we limited our search by using age as the secondary search term. Here is a list of the databases that we searched, and of course we began by looking at the database for the American Psychological Association and at PubMed. We also examined 2 databases that are unique to the U.S. Department of Defense. We were very surprised at how little information there is on the effect of age on perceptual speed performance in working age adults. We actually only found 2 studies in the open literature that reported the effect of age on performance. In contrast, we did find many studies that looked only at the elderly, and I would define that as people who were 75 years of age or greater. And we did find a lot of studies on clinical populations, particularly people with Parkinson's disease. The first of the 2 studies from referee journals was conducted by Shea in 1989. He used 2 perceptual speed tests, the Finding A's and the Identical Pictures test. Both of these are classic tests of perceptual speed. He actually conducted 2 studies, one in 1977 and one in 1984. We're going to use the 1984 data. You will notice that he has a large sample. The ages that he included were 22 to 91, and he did find a significant age effect. In this graph, you can see that after about age 35, there is a general linear downward trend in performance, and it is pretty much the same for both tests. The second study we found was by Heil in 1999. He used the dial reading test, which was developed in World War II by the Army aviation psychologists, as a measure of perceptual speed. It was developed along with the table reading test, which I'm going to talk about in a bit. The dial reading test was eventually dropped from the aircrew selection battery sometime after World War II in favor of the table reading test. This is the only study that we found that used current air traffic controllers as subjects. Again, it has a good sample size, and the age range, as far as I can tell, is 25 to 59. I say as far as I can tell because the information is not explicitly given in the report. I had to infer it by looking at the graphs he provided. I apologize for the quality of this graph, but we had to Xerox it off of an old tech report, and this was the best that we could do. The linear regression of age on the score is shown by the dotted line, and as you can see, it's effectively flat. Heil added a quadratic term to the regression, reran the analysis, and found a significant effect of the quadratic term. However, it only increased the R-squared by 0.01, which most of us believe is not operationally significant. Our second source of information was cognitive batteries that we knew had been used in pilot selection. We located 5 batteries that were used in either ab initio pilot selection or commercial pilot selection. Only 3 of them had manuals or published data that we could use. The first of these is CogScreen by Dr. Gary Kay. This battery contains 4 tests that may assess perceptual speed. Dr. Kay's study was conducted on current U.S. airline pilots, and you can see again that he had a good sample size. The age range was from 24 to 68, and he divided his subjects up into 6 different age groups. He had 2 types of measures: speed, which is essentially reaction time, and throughput, which is a weighted combination of speed and errors. Of the 4 tests of interest, speed correlated with age from 0.33 to 0.21. So as you can see here, as your age increases, your reaction time increases, and that's not surprising. He also calculated the correlation between throughput and age and found it to range from negative 0.35 to negative 0.23. Again, your throughput drops as you age, which isn't surprising. Dr. Kay also compared successive age groups to identify where performance differences occurred. He only found differences on 2 of the 4 tests, and only between the group that had 40 to 44-year-olds versus the group with 45 to 49-year-olds. The second battery is that of the multidimensional aptitude battery by Jackson. This battery contains the digit symbol test, which is a classic test of perceptual speed. The study had 1,600 subjects with 200 subjects per age group, and Dr. Jackson was looking at ages 16 to 64. Here are the results from his study, and as you can see, there are obvious performance decrements beginning about age 35. We can also see that performance is flat from about 18 to 35. The next source of results are the studies that John Trent and I authored. The first one I want to discuss uses the table reading test in its paper and pencil form. This is the test I mentioned earlier. It was originally developed in World War II for aircrew selection. It has remained in the U.S. Air Force aircrew selection battery since World War II because it has retained its predictive validity. I'm going to be talking only about the paper and pencil version. The data were collected between 2010 and 2015, and the candidates were ages 17 to 49. We have 2 sample groups. The first consists of officer candidates, and there are about 71,000 of them. This group includes people who want to be Air Force pilots, but this is the first selection test that they take, so none of them have passed any of the selection requirements to be an Air Force pilot at this point. This is just the group that we call the pilot wannabes. The second group consists of over 4,800 pilots. All of these pilots had completed successfully initial flight training, which consists of light single-engine aircraft training. Here are the results for the two groups. Now, I'm sure the first thing that you'll notice is the big drop in performance of the pilot trainees starting at about age 31. The only explanation we have for this concerns the sample sizes for ages 31 and 32. For age 31, there are 12 subjects in that group, and for age 32, there are 9. These are quite small groups compared to the others, so we think that we're looking at some type of statistical abnormality. If we look at the officer candidates, what we see is a slow rise, basically to about age 23, maybe 25, and then a plateau, and then a slow decline. The large fluctuations that we see around age 39, again, probably are caused by small sample sizes. Next, I'd like to talk about two studies that I conducted using the tabular speed test. This is a very, very close sister to the Air Force's table reading test. The first study was conducted using the paper and pencil version of this test. It included 429 students in a professional flying curriculum at a major U.S. university, and it also included 170 low-time commercial pilots. The testing was conducted between 2005 and 2008. In this particular study, the candidates were between ages 17 and 52. The second test was conducted with a computerized version of the tabular speed test. All of the data was collected last year in 2024, and the students were ages 17 to 23 years old. There were 169 of them, and they were all enrolled in one of two national flying schools. These schools were both extremely selective, and this test was administered relatively late in the selection process. Consequently, these data are likely to be very range restricted. Okay, here's the data, and what you can see first with the paper and pencil version is again a relatively flat area from about age 19 to about 34 or 35. You then see this drop and these wild fluctuations. Again, the fluctuations probably are the result of small sample sizes at these older ages. The blue dotted line is for the computerized version of the test. From ages 19 to about 23, these scores aren't terribly different from those of the paper and pencil group. We wanted you to be able to compare the three pilot groups with the officer candidate group, so we put all of them on one graph. What you'll notice immediately is that the Air Force pilots, the ones who have completed the first phase of flight training, outperform everybody else. It's also pretty clear that the two students groups perform better than the officer group. Okay, what can we conclude? Well, the first question we wanted to answer was what age range has the best performance? That was pretty consistently shown to be somewhere from the late 20s to the early 30s. We didn't show you all of the data that we found, but we did find data for younger individuals, and we do see a relatively rapid increase in scores from age 16 to about 19. I think this is a caution for us not to be testing this ability too early. The second question we wanted to address is when did the decline occur? Well, it appears to begin sometime between age 35 and 45. The interesting thing about these data is that it actually looks like the pilots are declining faster than the civilian subjects. We don't have an explanation for this, and it seems rather illogical. The only thing we can say is the studies examining pilots were collected more recently than some of the other studies. Perhaps there's been something changed in the cohorts, or perhaps there's something different about our measurement methods. We simply don't know. Like all studies, ours has certain limitations that we want to point out. First, there are very few studies on the effects of age on normal working age adults. Second, some of our analyses were hindered by the fact that the authors did not report the sample sizes for some of the age groups. And third, as I noted earlier, some of these older groups had very few subjects. So again, we should be careful about interpreting the data. Thank you for your time.